Hello everyone. In this video, we are going to discuss about mole concept and molar mass from the chapter Some Basic Concepts of Chemistry, Chapter 1, Class 11, Chemistry. You see, we know that atoms and molecules are extremely small in size. And if we consider a very small amount of any substance, for example the tip of this pen, there will be a very large number of atoms or molecules present in it, which can't even count in a normal way. So, to count the entities means it can be the atoms, molecules, particles, electrons or ions. That is, to count the entities at the microscopic level, we use a convenient unit which is mole. You see, in SI system, the SI unit of amount of substance is taken as mole. Its symbol is MOL, mole. You see, just like we use 1 dozen for 12 items. That is, 1 dozen is equal to 12 entities, 12 items. These entities can be the apples, that is 12 apples is equal to 1 dozen of apple. Okay, 12 bangles, 12 pens, anything. Entities can be anything. Apples, bangles, pens, pencils, whatever it is. 1 dozen, that is the numerical value of dozen, that is 12. Okay, similarly, we use score for 20 items and gross for 144 items. So, to count entities like bangles, mangoes, cups, etc., we use dozen, score, gross, etc. Similarly, to count the number of molecules, to count the number of atoms, particles, to count the number of electrons, ions, we use mole. Okay. See, 1 mole contains exactly 6.022140076 into 10 raised to 23 elementary entities. That is, 1 mole is actually equal to 6.022. We are rounding off this into this number, 6.022 into 10 raised to 23 entities. That is, mole is a number. Okay, mole is a number. Its numerical value of, the numerical value of 1 mole is 6.022 into 10 raised to 23. See, dozen, its numerical value is 12. Score, its numerical value is 20. Similarly, mole is also a number. Its numerical value is 6.022 into 10 raised to 23. Okay, so 1 mole is equal to 6.022 into 10 raised to 23 entities. These entities can be the atoms, particles, ions, molecules, etc. See, we have given a separate name for this number 6.022 into 10 raised to 23, and that name is Avogadro number or Avogadro constant. That is, Avogadro number or Avogadro constant is 6.022 into 10 raised to 23. That is, we have given a separate name for this number 6.022 into 10 raised to 23, that is Avogadro number Na. Okay, so Avogadro number Na is actually equal to 1 mole, that is actually equal to 6.022 into 10 raised to 23. If we consider 1 mole of hydrogen atoms, there will be 6.022 into 10 raised to 23 atoms. That is Avogadro number of hydrogen atoms. If we consider 1 mole of water molecules, that means there will be 6.022 into 10 raised to 23 number of molecules. That is, in 1 mole of water molecules, there will be Avogadro number of molecules. And in 1 mole of sodium chloride, there will be 6.022 into 10 raised to 23 formula units of sodium chloride. That is, 1 mole of a substance that always contains the same number of entities no matter what the substance may be. That is, 1 mole of hydrogen atoms contains 6.022 into 10 raised to 23 atoms. That is Avogadro number of atoms. If you consider 1 mole of oxygen atoms, there will be Avogadro number of oxygen atoms, that is equal to 6.022 into 10 raised to 23 atoms. Mass of a carbon-12 atom that was determined by a mass spectrometer, and it found to be equal to 1.992648 into 10 raised to minus 23 gram. That is, mass of one carbon-12 atom is equal to 1.992648 into 10 raised to minus 23 gram. That is 1.992648 into 10 raised to 23 gram. That is actually equal to mass of 1 carbon 12 atom. That means in 1.992648 into 10 raised to 23 gram, there is 1 carbon 12 atom. Okay, see, 1 mole of carbon weighs 12 gram. Then that is the mass of 1 mole of carbon is equal to 12 gram. Then what will be the number of atoms in it? How many carbon atoms will constitute 12 gram mass? See, in 1.992648 into 10 raised to minus 23 gram, there is 1 carbon 12 atom. Okay, so in 1 gram, there will be 1 by 1.992648 into 10 raised to minus 23 carbon 12 atoms. Okay, then in 12 gram, there will be 12 into this value, that is 12 into 1 is 12 divided by 1.992648 into 10 raised to minus 23 carbon 12 atoms. That is in 12 gram, there are 12 divided by 1.992648 into 10 raised to minus 23 carbon atoms. Okay, you see, when you find out this ratio, you will get in 12 gram, there is 6.022. That is 12 divided by this value will give you 6.0221367 into 10 raised to 23. That is in 12 gram, there will be 6.0221367 into 10 raised to 23. Okay, carbon atoms, carbon 12 atoms. Okay, that is the number of atoms in carbon 12 isotope. Okay, in 12 gram, that is 6.022 into 6.0221367 into 10 raised to 23. The number of atoms in carbon 12 isotope, that is actually equal to the number of atoms in 1 mole. Okay, you see, in 1 mole, there are 6.022 into 10 raised to 23. That is, we are just rounding off this value to the 6.022 into 10 raised to 23 atoms. Okay, that is 6.022 into 10 raised to 23 atoms per mole. Okay, because in 1 mole there are 6.022 into 10 raised to 23 atoms. That means there are 6.022 into 10 raised to 23 atoms per mole. That is, in 1 mole there are this much atoms. And this number, this is actually known as the Avogadro constant or Avogadro number Na. That is, 1 mole is the amount of a substance that contains as many discrete entities are there or atoms in exactly 12 gram of carbon 12 isotope. So 1 mole is actually equal to 6.022 into 10 raised to 23. So I hope the mole concept is clear to you. Now let us see what is molar mass. See, molar mass, it is actually the mass of 1 mole of a substance in grams. That is, mass of 1 mole of a substance in grams, that is actually called as molar mass. In 1 mole of a substance, there are 6.022 into 10 raised to 23 atoms or molecules. So, mass of this much number of atoms or molecules, that is actually called as molar mass. Okay, see, the molar mass in grams, that is numerically equal to the atomic mass in U or molecular mass in U. U means unified mass. We have already discussed about that. And the molar mass in grams, that is numerically equal to the atomic mass in U or molecular mass in U or formula mass in U. For example, the molecular mass of water in U is 18.02 U. Okay, then molar mass of water will be 18.02 gram per mole. Similarly, the formula mass of sodium chloride, that is 58.5 U. Therefore, the molar mass of sodium chloride will be 58.5 gram per mole. So that is mass of 1 mole of a substance in grams, that is actually called as molar mass. See, in 1 mole of a substance, there are 6.022 into 10 raised to 23 atoms or molecules. So, the mass of this much number of atoms or molecules, that is actually called as molar mass. And you see, molar mass in grams, that is numerically equal to the atomic mass in U. Okay. So, in this video, we have discussed about the mole concept and molar masses. I hope those two concepts are clear to you. Thank you.